here in that graphic organizer, and let's talk about that other rule. So, recap, okay? We so far have 3 rules, technically 4. I didn't put the 0 exponent in there because it's pretty simple, but we have our negative exponents. Remember, to make a negative exponent positive, you flip the power over the fraction bar. The exponent switches its sign. We have the product of powers, so multiplying powers with the same base. Remember, this is the rule where you add the exponents, and I add the exponents because x cubed times x to the 5th, right? 3 plus 5, squash them together, you get an x to the 8th. That's why we add those ones. And then Friday, I introduced the power of a power. Okay, so the power of a power is where you multiply the exponents. And I multiply the exponents because x squared to the 4th power is x squared times x squared times x squared times x squared. You have 4 x squareds together, and then that's actually the rule from before where you take 2 plus 2 plus 2 plus 2, which is the same thing as taking 2 times 4. Which is why we can take that shortcut and just multiply the exponents. Okay, now, the last one is a power of a product, which I think in itself is really pretty simple, but when it's combined with all of the other rules, that's where it can get a little tricky. So, when taking the power of a product, every factor gets the exponent. Every single one. So, when it looks like something like this, okay, and I'm going to do a simple one first. If I have x, y squared. So notice, the parentheses, really important here. Because this means I'm squaring everything inside the parentheses. I'm going to take x squared, and I'm going to take y squared. Now the reason why, once again, if I were to expand this out, xy squared would be xy times xy, right? Squaring something, multiplying something by itself. And if you expand it out and then squash it back up, you get x times x, x squared. Y times y, y squared. So ones like that, really pretty simple, but where they get kind of tricky is where we have something like this. If I have like 3x cubed y squared to the 4th power. So I'm kind of combining rules here. Okay? Now, every single thing inside those parentheses gets the exponent. Everything in here gets raised to the 4th power. Everything. Including the 3. That's the biggest thing that people forget about. But remember, this means 3x cubed squared times 3x cubed squared times 3x cubed squared times 3x cubed squared. Which is 3 times 3 times 3 times 3. 3 to the 4th power. And x cubed times x cubed times x cubed times x cubed, which is x cubed to the 4th power, and y squared times y squared times y squared times y squared. Right? Everything is getting multiplied by itself 4 times. Everything gets raised to the 4th power. So we would take 3 to the 4th power, which is 81. Now, x cubed to the 4th power, that's this rule, right? Power of a power. This is x cubed times x cubed times x cubed times x cubed. If you did the repeated addition, it'd be 3 plus 3 plus 3 plus 3, which is the same thing as 3 times 4, so x to the 12th. And then same rule here, power of a power, 2 times 4 would be y to the 8th. Okay, questions on that? Okay, let's jump over and let's finish up some of these examples. Okay, number 7. Okay, let's do 5x to the negative 3rd. 5x to the negative 3rd. Okay, so remember, everything in the parentheses gets the exponent. So I think especially for these first ones, it's really important to show this step here. Everything in there, including the 5. So you're going to take 5 to the negative 3rd, and you're going to take x to the negative 3rd. Now, of course, we know the problem here. You can't have negative exponents. The 5 has a negative exponent. The x has a negative exponent. both of those need to be moved to the denominator, the 5 and the x, which means the 3's become positive, throw a 1 in the numerator. And then the last thing, you don't ever want to leave something is 5 cubed. If you can do 5 cubed, 5 times 5 times 5 is 125. So 1 over 125x cubed. Okay, number 8. Let's do 3 times, and then in parentheses, x cubed squared times, and then in parentheses, negative 2x cubed. Now, we talked about this a little bit on Friday, that order of operations is always a thing, and parentheses would always come first. There are parentheses, but I can't do anything inside the parentheses, so exponents come next. So I need to take care of the exponents outside the parentheses, okay? Now, I'm supposed to square everything in the parentheses here. The 3, not in the parentheses, so the 3 is going to stay the 3. But I do need to take x cubed squared. This is the rule from Friday. This is the power of a power. You're going to multiply those together and you get x to the 6th. Now the second set of parentheses, this says I'm supposed to cube everything inside the parentheses, and guess what? The negative 2 is inside the parentheses. So you're going to cube everything, the negative, the 2, and the x. So we're going to take negative 2 cubed, which is negative 2 times negative 2 times negative 2, which would be negative 8. And you're going to take x cubed.
Please send Dustin Cooter to the office.
Okay, he's on his way.
Thank you.
Which is just x cubed. Okay, now, this is the rule from, what would it have been? Thursday, last week. We're going to rearrange things, multiply the things together that we can. I'm going to take 3 times negative 8, which is negative 24. Then when I take x to the 6th times x cubed, this is also the rule from Thursday. What do I do with these exponents, the 6 and the 3? You'd add them, right? Because there's 6 of them, and then 3 of them. 6 plus 3 would be x to the 9. Negative 24x to the 9. Now remember, we can't leave an answer with a negative exponent. That's not a negative exponent, that's just a negative number. No problem with a negative number, just can't have a negative exponent. Okay, number 9. In parentheses, 8x cubed y to the 5th squared. And then the second set of parentheses, xy to the negative 4. Now, we need to get rid of those parentheses. That's typically the first thing you're going to want to do is get rid of the parentheses. So the first set of parentheses, everything in here is getting squared. So you're going to take 8 squared. 8 times 8 is 64. Now I'm going to kind of show a little step in here a little bit. When you take x cubed squared, that's what it would look like if you were to show that. But what do I do with those exponents? That you multiply those, because that's the rule from Friday. So this would be x to the 6th. You're going to do the same thing here. You would take 5 times 2 and you get y to the 10th. Now the second set of parentheses, everything in there gets raised to the negative 4th power. And it's just an x, so it's going to be x to the negative 4th. It's just a y, so it's going to be y to the negative 4th. Now there's a couple different ways you could do this. I know some people see the negative exponents, they want to move them first. But what I will tell you to do before you move stuff, before you move the negative powers or the negative exponents, if you can simplify this at all, I would. So what I mean by that, I've got an x to the 6th and an x to the negative 4th. There's no reason to have x's in 2 different places. I could write this as 1 power, okay? Now, whenever you're trying to figure out what rule to apply, I know there's negative exponents, which can be kind of hard to think about. So to figure out what the rule's going to be, think about them as positive exponents. If it was x to the 6th and x to the positive 4th, you'd have x to the 6th and x to the positive 4th. What would you do with the 6th and the 4th? You'd add them, right? So you do that, except it's a negative 4. So we're going to have 64. X to the 6 plus negative 4 would be 2. And you do the exact same thing with the y's, right? Y to the 10, y to the negative 4, 10 plus 4 would be y to the 6th. Notice, if I simplify this and write those x's and y's as one power, I don't have any negative exponents, so I don't have to worry about moving anything anyway. So you can usually save yourself a little bit of work if you try to simplify first before moving stuff, okay? Okay, number 10. In parentheses, xy cubed to the negative 2nd. And then in parentheses, xy cubed. Okay, once again, generally the first thing we're going to want to do is get rid of those parentheses. So these first set of parentheses, I'm supposed to take everything in here to the negative 2nd power. So x to the negative 2nd power will just be x to the negative 2nd power. Now, when I do y cubed to the negative 2nd power, that's a power of a power. That's Friday's rule. What do I do with the 3 to the negative 2? You multiply them, so it's going to be y to the negative 6th. Now, the second set of parentheses, I see a cubed. What's being cubed? The y, and just the y. Because there's no power, there's no exponent on the outside of the parentheses, so really, these parentheses aren't really doing anything, so you can just drop them. It's just going to say xy cubed. Now remember, before you start moving your negative powers, your negative exponents, if I have an x to the negative 2nd and an x, there's no reason to have this x in 2 different places. I can rewrite this as one power. And we do that by adding the exponent. So I would take negative 2 plus 1 would give me x to the negative 1st. And for the y's, add the exponents. Negative 6 plus 3 would give me y to the negative 3rd. Now, sometimes it is unavoidable. I do have negative exponents now. I can't have x to the negative 1st or y to the negative 3rd. Both of those are going to need to be moved to be 1 over xy cubed. If you want to write x to the 1st, no problem. You can, you don't have to, doesn't matter either way. Okay, couple more. Number 11, in parentheses, negative 3, xy to the negative 2nd, all squared. And then in parentheses, 2x to the negative 2nd, y cubed, all to the negative 3rd. Okay, now once again, kind of the first rule of thumb, let's get rid of these parentheses. So for this first one, you need to square everything in here, including the negative, including the 3, the x, and the y to the negative 2nd. So when you take negative 3 squared, that's negative 3 times negative 3, which would be a positive 9. You're going to take x squared. And then when you take y to the negative 2nd squared, the power of a power, this is the multiplying those exponents. It's going to be y to the negative 4. Now, for the second set of parentheses, we're going to have to do this in a couple extra steps for one thing, okay? Everything in here needs taken to the negative 3rd power. Now, I think whenever it comes to negative exponents, whenever we talk just about negative exponents, like, okay, I got negative exponents, no problem. But whenever we talk about the power of a product and start putting all these other rules in, or where people start kind of maybe going a little too fast. So what I would say on these ones, I almost guarantee you, the more work you show, the better you'll do. If you try to start skipping steps and doing stuff in your head, that's usually whenever students start messing up. Because what happens here, when you take 2 to the negative 3rd, I can't evaluate 2 to the negative 3rd. Because it's a negative exponent. I'm going to have to move it and then evaluate it. So show this step. Okay? Now, x to the negative 2nd to the negative 3rd, power of a power, you multiply these. So it would be x to the negative 2 times negative 3 would be a positive 6. Same thing with the y. Y to the 3 times negative 3 is going to be a negative 9. Now what I would do next, kind of like on the last ones, for me there's not really any reason to have an x squared and an x to the 6th when I could write those as the same power. So we'll leave the 9 the same. Okay? X squared and x to the 6th. How many x's would that be being multiplied together? X squared and x to the 6th. 8. So it'd be an x to the 8th. Now for the y's, it'd be y to the negative 4, y to the negative 9. Add those, we'd have y to the negative 13. Now I do still have the 2 to the negative 3rd. I still cannot evaluate those. And you also cannot multiply the 9 and the 2. Okay, because here's the thing. That 2 has a negative exponent, which means that 2 goes in the denominator. You can't multiply by the 9 because the 9 is in the numerator, the 2 is in the denominator. You can't multiply those together. The y also needs to be moved. So the 9x to the 8th stays in the numerator. The y moves to the denominator. And the 2 moves to the denominator. The negative 3 becomes a positive 3. Okay, and then the very last step, we wouldn't want to leave it as 2 to the 3rd power. 2 times 2 times 2 would give me 8. So your answer would be 9x to the 8th over 8y to the 13th. I've said it once, and I'll say it again. I promise you, the more work you show, the better you will do with these. Okay? Let's do one more like that. Number 12. Alright, in parentheses, negative 4x to the negative 2nd, y to the 4th, all to the negative 2nd power, and then in parentheses, negative 3x cubed, y to the 5th, all squared. Okay, first thing, to get rid of those parentheses, in that first set of parentheses, everything needs raised to the negative 2nd power. Now I'm telling you, anytime you take a number raised to a negative power, you're just going to have to leave it. So this is going to look like this, negative 4 to the negative 2nd. I can't evaluate that until the negative 2 becomes a positive 2, and I do that by moving it to the denominator. Now, x to the negative 2nd to the negative 2nd, power of a power, multiply those together, you get x to the 4th. Do the same thing with the y's. 4 times negative 2 would be y to the negative 8. Now, the difference here, when I take negative 3 squared, can you take negative 3 squared? Negative 3 times negative 3? You can do that. Because the 2 is positive, that's going to give you 9. You can go ahead and evaluate the positive exponent. I can't evaluate this because it's a negative exponent. I'm going to have to move it, then evaluate it. Does that make sense? Okay. And then we're going to take 3 times 2 and give me x to the 6th. 5 times 2 give me y to the 10th. Now once again, this is what I would do. It's not the only way to do these. I prefer to simplify next, so instead of having x to the 4th and x to the 6th, let's write this as 1 power. So we're going to leave the negative 4 to the negative 2nd for one more step. X to the 4th and x to the 6th. 4 plus 6 would give me x to the 10th. Do the same thing with your y's. Y to the negative 8 plus 10 would be squared, and we still have the 9 there. Now, the only thing that has a negative exponent now is the negative 4. So, I'm going to write the 9 in the front just because that's more typically how it'll be written. So, 9 x to the 10th y squared. That stuff's going to stay in the numerator, not going to move that. Now, the negative 4 has a negative exponent, so you're going to move that base to the denominator. But the base doesn't change. That negative 4 is going to stay a negative 4. What changes is a negative 2. The negative 2 becomes a positive 2. And then my very, very last step, 9x to the 10th y squared, that's going to stay the same. But negative 4 squared, negative 4 times negative 4 gives me a positive 16.